Hey, what's up, guys? This is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 127 Random Signals. In this lecturette, we are going to see how we can solve probability problems for joint continuous random variables using their joint probability density functions. Now, the technique that I'm going to share with you is fairly technical. So this entire lecturette will be devoted to learning and understanding this technique. In order to find the probability of event A, we follow these three broad steps. The very first step is to plot the region of non-zero probability. Now, understand that the region of the non-zero probability is not the plot of the probability density function. It is the plot for that region over which the probability density function is non-zero. Almost every time your joint PDF is going to be specified something like this. F of x comma y is some function g of x comma y for a region h of x comma y. It is zero otherwise. This region h of x comma y is the region of non-zero probability. So I repeat again, the region of non-zero probability is not the plot of the joint PDF. In fact, if you were to try to plot the joint PDF, it will be very difficult to begin with. And regions of non-zero probabilities are usually not complex looking like the probability density functions. They are usually simple. So if you find yourself trying to plot a region that you're unable to plot because it is some crazy fancy equation, then most likely you're looking at the wrong equation. Look the other way. Step 2. In order to find probability of event A, we will first plot the region A and find its intersection with the region of non-zero probability. This intersection between region A and the non-zero probability region is going to give you the limits of integration for the joint PDF. Step number 3 is to evaluate the integral over the region of non-zero probability intersection A. So we are going to double integrate the joint PDF or the region of non-zero probability intersection A. So let me put these three steps in a nice graphics here so that you are able to appreciate the step or this technique further. So step number 1 is to plot the region of non-zero probability. So your non-zero probability region will be plotted, and let's say that for some reason this right here is the region of the non-zero probability NZ. The next step, step number 2, will be to plot the region A whose probability you are interested in. So let's say that this region right here is my region A. In the same step, I will also find the intersection between the region of non-zero probability and event A. Everything that is outside of this intersection will not be considered because your probability density function is 0. Now remember that your probability density function is non-zero only in the region of non-zero probability. So if we want to find probability of event A, we better look at the intersection of NZ and the region A. Step number 3 is to evaluate the double integral of the joint PDF or that region NZ intersection A. So these are the steps that you're going to use to find the probabilities of different events or different regions. Let me also use this opportunity to discuss on some other problems that you'll be solving with joint probability density functions. One of the problems that you'll be interested in is finding the marginal PDF of the individual random variables. So as discussed, the marginal PDF is obtained by integrating the joint PDF with respect to the other random variable from negative infinity to infinity. But because of the non-zero probability region, this limits for the integration will depend on NZ. Similarly, f of y will be obtained by performing an integration, a single integration of the joint PDF with respect to x, and the limits will depend on NZ. So you may be also interested in finding the marginal PDFs like this. Another kind of problem that you'll be interested in is to find constant in the joint PDF. To find constants, use this principle. Double integration of the joint PDF over the region of non-zero probability gives you value equal to 1. This equation will help you to solve for constant that is hidden in the joint PDF. So in summary, this lecturette covered some techniques used to find the probabilities of different events pertaining to joint continuous random variables, and we also discussed how to find marginal probability density functions and any hidden constant in your joint PDF. I think it's a good time to stop this lecturette right here. Although this is short and sweet, this lecturette is really very important to have any other problems discussed and making this lecturette even any longer.